Hi everyone, my name is Eric Fu, and today I'm going to be walking through the big picture of web development and then the essential pieces like HTML, CSS, JavaScript, and how they connect to servers and databases. This video is for my CS5610 midterm evaluation for my class at Northeastern University. So before we move forward, here's just a quick look at a concept map about all the topics we've covered so far in class. So at a high level, web development has three building blocks. HTML, which is the structure and skeleton of the web. It essentially gives meaning and structure to content, so browsers and assistive technology know what each piece is. If the web page were a house, HTML would be the framing and rooms. Next, CSS styling and layout. So using this house metaphor, CSS would be the paint, layout, and interior design of a house. It controls color, spacing, typography, and responsive layouts so the same content looks great on any screen. With CSS, we turn the bare structure into usable, polished experience. Next, JavaScript. JavaScript would be the brain and the wiring. It essentially listens for user actions, fetches data, and updates the page without reloads, making apps feel alive and smooth. JavaScript is what turns a static site into an interactive application. So now moving on more specifically into HTML, structure, and semantics. So HTML has tags with opening and closing parts to mark meaning, like headings, paragraphs, or links. Tags can have attributes that add details. Two that you hear pretty commonly are ID and class. An ID is a unique name for one element, while a class is a label you can reuse across many elements. Adding on to that, attributes are little add-ons that enhance HTML tags. They add extra meaning, behavior, configuration without changing the tag itself. We can think of them as labels and settings. So ID gives a unique name for one element. Class groups elements for styling. href tells a link where to go. src tells an image where to load from. And alt describes that image for accessibility. Examples in plain English you can think of are a link with an address, an image with a source and description, or a button with a unique ID and reusable class. In short, tags define what something is, while attributes define how it behaves, looks, or is identified. So for structure, I typically like to think in two clear sections, the head and the body. The head of HTML is for more behind the scenes information, which includes meta tags for character encoding, mobile viewport, page title, and links to different CSS styles. On the other hand, the body is everything users actually see. So with structuring, we can use semantic elements so that our structure is meaningful. Some semantic elements include header, footer, section, and article. When nothing else fits these cases, we can use div for block containers and span for inline bits of content. And these help both with accessibility and search engines. Now moving on to CSS, styling your web pages. CSS, as previously mentioned, controls the look and layout. So with CSS, we can target elements with selectors. The most basic ones are element selectors by tag name, dot class selectors for shared styles, hashtag ID for a single unique element, and the parent, child, and descendant patterns to kind of help us reach exactly what we want to target. A key habit here worth mentioning is to not use the exclamation mark important. If basically a style isn't applying, we would like to fix the selector or the order instead of just forcing everything on your CSS. And this just keeps your CSS much more predictable and easier to maintain. Now moving on to the box model. The box model is basically a mental model for layout. Essentially, every element is a box with content in the middle, padding hugging that content with another border around it, and finally a margin as kind of the outside breathing room. So for example, if something looks too big, we could check padding and border. while on the other hand, if something is too far from its neighbors, we could check the margin. One important thing to note is there's kind of two settings regarding box sizing, and these are content box, which is the default, and border box. So in content box, the width refers to content only, and padding and border make the box grow. While on the other hand, border box, the width includes all of content, padding, and border, so the outer size stays what you set. In my experience, most teams prefer border box for the more predictable layouts. Moving on to Bootstrap, a framework for responsive design. So Bootstrap is a ready-made design toolkit and front-end framework that gives us a responsive grid, pre-built components, and utility classes, so developers can ship layouts fast without having to reinvent CSS. Many use it for its speed, consistency, and mobile-first responsiveness out of the box, and it's great for prototypes and production since it handles a lot of cross-browser quirks and accessibility defaults. Many still can customize your site while using Bootstrap so that it doesn't look too bootstrappy, and this saves us a lot of time, so we don't have to spend as much resources on the basics. Now moving on to JavaScript. So as previously said, JavaScript kind of brings your pages to life. It's what responds to the clicks, what fetches data, and what updates the page. So functions are the essential building blocks of JavaScript, and functions encapsulate discrete tasks with clear inputs and predictable outputs. Effective functions are single-purpose, well-named, and reusable, enabling composition of larger features from simpler parts. We prefer purity for easier testing and reasoning with these functions, and consistent parameter handling and return values improve readability, maintainability, and reliability. So event handling, making pages interactive. Event handling connects user actions to application behavior through targeted listeners and concise handlers. Best practice is to update application state first and reflect changes in the UI while honoring native behaviors and accessibility requirements. High-frequency events should be controlled with debouncing or throttling to maintain performance and responsiveness. DOM manipulation, changing HTML CSS dynamically. So DOM manipulation updates content, attributes, and styles in real time to reflect application state. Efficient approaches minimize layout thrashing, batch-related changes, and separate structure from presentation. The recommended flow of changing DOM or manipulating DOM is to read the current state, compute the necessary differences, and apply focused updates, yielding consistent performant interfaces without the need for full page reloads. Now let's touch on some modern JavaScript features, the first of which are arrow functions. So arrow functions provide a concise function syntax with lexical this binding, making them very well suited for callbacks and functional patterns. They reduce boilerplate, support implicit returns for simple expressions, and avoid rebinding of this, arguments, and prototype. They are not constructors and are best used for short stateless operations where clarity and brevity are your priorities. Next concept would be regarding let and const. So let and const introduce block scoping and temporal dead zones, and this prevents many hoisting errors that are typically associated with var. Using const by default for bindings that should not be reassigned is the main purpose, while using let for values that you do anticipate changing. It's important to note that const enforces immutability of the binding and not the object's contents. This discipline improves correctness, readability, and tool-assisted optimization. Now moving on to modules. So ES modules enable explicit file level dependencies via importing and exporting, supporting statistical analysis, tree shaking, and a predictable load order. They encourage clear boundaries, reuse, and testability by surfacing only the public API of each module. Adopting modules standardizes composition across the codebase and simplifies bundling, refactoring, and incremental deployment. Oftentimes, you'll hear terms like import and export and loading scripts as type equals module in the page. Conceptually, you can kind of just think of this means that, hey, we can treat this file as a modern module so we can organize code cleanly. So just to touch on some functional programming concepts. So promises. Promises model values that resolve in the future, enabling structured asynchronous control flow and error propagation. They replace nested callbacks with a clear lifecycle, pending, fulfilled, and rejected, and compose via chaining and aggregation. Consistent promise handling improves readability, centralizes error handling, and simplifies integration with async and await. Now moving on to closures. Closures essentially allow a function to retain access to its lexical environment after that environment has returned. This enables encapsulation of private state, creation of function factories, and deferred execution with remembered parameters. Proper use of closures reduces global state, but care should definitely be taken to avoid unintended memory retention and overly persistent references. Array methods map and filter for data manipulation. In short, map transforms each element into a new value, producing an array of equal length, while filter selects elements based on a predicate, producing a potentially smaller array. Both are declarative, side effect free patterns that improve clarity over manual loops. They compose cleanly, enhance testability, and align with functional programming practices for predictable data pipelines. Understanding the document object model, or DOM. So the DOM was mentioned previously, but here we can do a little deeper dive. The DOM is essentially the browser's live tree structured model of a page, exposing nodes like elements, text, and attributes via a standard API. It links structure, style, and behavior, scripts, read, update nodes, and the engine recalculates styles, computes layout, and paints the screen. Efficient manipulation favors targeted updates, bashing mutations, and avoiding layout thrashing. Events travel the tree by capturing and bubbling, enabling event delegation on parent nodes for performance and simplicity. Finally, just a short aside. When handling all of these different languages and different codes, I think it's important to note that it is essential to use ESLint and Prettier. In short, ESLint is a linter that catches common mistakes, while Prettier formats everything consistently. And these two things used in unison just allows you or your team to focus on the logic and not worry too much about spacing or formatting of the code. Now moving on to web architectures and a brief overview. So here we're essentially just zooming out and connecting all the pieces. So static files and client-side rendering. You can ship a site as static files with no backend, enabling simple deployment, strong caching, and excellent baseline performance. Something like this is perfect for making a personal portfolio, documentation, or small tools. When you need data or user accounts, you'll talk to an HTTP server. The browser sends HTTP requests and receives responses, usually JSON for data. You'll typically hear the core methods: get to read, post to create, put to update, and delete to remove. And these four verbs essentially cover almost every data action that you might need. As for servers organize behaviors into routes. We can conceptually think when the server gets a GET on this path, run this handler. On the back end, we say that the server listens on a port, meaning it's waiting for requests. So with this forms the classic 3-tier full stack model with the client, backend, and database. The client is what the client in the browser renders the UI. The backend is a server that exposes routes and business logic, and the database is where we store and query data. Now moving on to backend development with Node, JS, and Express. So Node runs JavaScript on Google's server using their V8 engine with an event-driven, non-blocking input-output model. It's great and excels at high concurrency APIs, real-time applications, and streaming, and is backed by a vast NPM ecosystem. For CPU-bound tasks, we can pair Node with worker threads, queues, or specialized services. So Express, a framework for web applications. Express is a minimal Node framework for HTTP servers. It provides routing and a composable middleware pipeline for JSON parsing, authorization, logging, CORS, and error handling. The lean core scales from simple REST endpoints to full web applications. RESTful APIs, client-server communication. REST models data as resources addressed by stable URLs and manipulated with standard HTTP methods that we mentioned. Interactions are stateless, use clear status codes, and typically exchange JSON. Consistent resource naming, error shapes, caching, and versioning improve reliability and evolution. Now moving on to databases and a brief introduction to MongoDB. So MongoDB is a document-oriented database. MongoDB stores JSON-like documents in collections, allowing flexible nested data that matches application shapes. It offers horizontal scaling, rich indexing, atomic single document writes, and optional multi-document transactions. The aggregation pipeline prepares analytics and API-ready responses in database. Mongoose, an ODM for MongoDB. So Mongoose adds schemas, validation, and a clean model API on top of MongoDB. Features like hooks, virtuals, population, and lean reads support common patterns with clarity and performance. The result is more predictable data access and better maintainable domain models. Now moving on to queries, CRUD operations with MQL. So MQL covers create, read, update, and delete, also known as CRUD. MQL also has sort, limit, and skip, which supports pagination, and indexes essentially must match query patterns for speed. Aggregation stages such as match, group, project, and sort compose for reporting and reshaping. Now moving on to networking and AJAX. So AJAX, asynchronous JavaScript and XML, refers to background requests without page reloads, typically via fetch returning JSON. It enables live research, inline validation, incremental updates while the UI stays responsive. Good practice includes explicit loading states, actionable errors, and smart caching. A little more on HTTP methods: get, post, put, and delete. HTTP methods convey your intent. As previously mentioned, get reads, post creates, put or patch updates, and delete removes. We compare them with consistent URLs, clear request response bodies, and meaningful status codes. These status codes, for example, are status code 200, 201, 400, or the most common one, 404. And this contract simplifies integration and debugging. Moving on to client-server communication. Client-server is a request-response exchange over HTTP. The client, in short, sends a URL, method, headers, and optional body, while the server validates, executes logic, and returns status, headers, and data, often in the form of JSON. Performance benefits from lean payloads, caching, and fewer round trips. reliability improves with idempotence, clear errors, and sensible timeouts/retries. So now we're going to do a bit of a deep dive into the three variable declarations within JavaScript: var, let, and const. So as previously mentioned, JavaScript gives us three ways to declare variables. They all store values, but they behave slightly differently in terms of scope, reassignment, and timing. Those differences directly affect safety, predictability, and bugs. So moving forward, I'll explain each one and I'll show the behavior in a live lab. So first of all, with var, var is the original way to declare a variable in JavaScript. It's considered legacy in modern code for two reasons. First, var is function scoped, not block scoped. That means if you do declare var inside an if block or something like a loop, that variable still exists outside that block as long as you're in the same function. So temporary values can unintentionally leak farther than expected. Secondly, var allows redeclaration in the same scope. So you can accidentally declare the same name twice and JavaScript won't complain, and that makes it easier to override something silently. Because of those two traits, leaking scope and silent redeclaration, var can create subtle bugs, especially in larger code bases. So here in our lab, we have, we can select var for our dropdown, and then we can run a scope test. So for this scope test, it basically declares a variable inside a block and then tries to read it outside the block. With var, it's still accessible. The explanation here says that var is function scoped so that it leaks out of the block scoped, and this is kind of the first red flag and shortcoming with using var. Now moving on to let. Let was essentially introduced to fix these issues. Let is block scoped, and a block can be defined as anything inside curly braces. If a let is declared in a block, it only exists within that block and it does not leak out. That makes control flow and temporary values a lot safer. Another thing to note is that let can be reassigned, which is useful for things like counters, accumulators, and values that change over time. But unlike var, let cannot be redeclared in the same scope. So if you try to define the same let name twice in the same block, you would get an error, and that basically protects against accidental overwrites. So let's switch the keyword to let, run the same scope test, and now the same block test throws or shows that the variable is not available outside. Here the explanation says let is block scoped, and this is exactly the behavior you would want in modern code. Now moving on, we can also run a reassign test. So now we're testing reassignment. Let allows the value to change. This is intentional. Let is for values that evolve during execution but are still safely scoped. Lastly, const. Const is also block scoped, just like let. The key difference is that a const binding cannot be reassigned, so once it's initialized, you cannot point that name at something else. This is useful for signaling intent. Declaring something with const says, hey, this identifier should always refer to the same thing within this scope. That type of coding just improves clarity for anyone that might be doing a code review or reading your code. One important detail to remember is that const protects the binding and not the internals. So for example, if a const refers to an object or array, you can still change the contents of that object array, but you just can't reassign the variable to a brand new object. So we can play around with the const in the lab. Switch this. Let's run the reassign test. So here the lab tries to change the value, and with const, the result shows that reassignment is not allowed. And that's the guarantee that const gives you. This name will pretty much always refer to the same binding. Another key difference is between all three of these variable declarations is how each one behaves before it's declared. var is hoisted in a loose manner. You can technically access it before the line where it's declared, and instead of throwing an error, it just gives you an undefined. That may sound convenient at first glance, but it can hide a lot of potential bugs. You might be using a variable too early and not realize it at times. On the other hand, let and const do not allow that to happen. They're in what's called a temporal dead zone from the start of the scope until the actual declaration line runs. So if you try to use them too early, the code throws immediately. That's basically a built-in safety feature, forcing you to declare first and then use. So here, let's change this to var, and let's run the temporal dead zone test. So here with var, reading it before the declaration does not throw, it just returns an undefined. This is the older behavior that could potentially mask mistakes. And here we can see that after declare, it returns now declared. Now let's look at the same thing for both let and const. So if we run the temporal dead zone test, so here we can read before declare, it threw a reference error, and after declare, it is now declared, and the same thing should be running for a const as well. And yeah, so with let and const, accessing the variable before it's declared throws immediately. The lab message calls us out as the temporal dead zone. That early failure is good and something that we want, and it prevents using a value before it's actually initialized. One place where the difference is especially visible is in loops and callbacks. With var, a loop counter is shared for all iterations because var is not block scoped. So if you create functions inside a loop using var, they all end up referring to the same final value after the loop finishes. With let, each iteration of the loop gets its own block scope and its own copy of the counter, so each callback captures the value it saw at that moment. This was a real-world pain in older JavaScript, and let essentially fixed it very cleanly. So a simple rule of thumb that I assume most people would follow when they use modern JavaScript with these three variable declarations is use const by default, use let only if the value truly needs to change, and in most cases you would just typically avoid using var in any new code. This set of rules essentially communicates intent. Const says, as previously mentioned, that this variable should never be reassigned. Let basically says this variable will change, and var is just avoided because of leaking scope, silent redeclaration, and looser hoisting. So to summarize, for scope, var is function scoped while let and const are block scoped. For reassignment, let can change and const cannot be reassigned. For timing, var is hoisted loosely while let and const enforce a temporal dead zone. And for best practice, we default to const, fall back to let if something needs to change, and we do not introduce var in modern code. This combination gives code that's safer, easier to read, and easier to debug. A little demo demonstrating the differences between var, let, and const that were just explained. So first, I'll show the differences in scope. I'll basically declare three variables inside a block, one with var, one with let, and one with const, and then I'll try to use them outside the block. here we can just have a if statement, and then assign our variables. B and const C inside block, and now we'll just log all three values. And Copilot is doing a good job doing this. So as you can see by the comments here, we expect, because var is function scoped and let our const are block scoped, we expect var a to still be accessible with const b and const c and let b throwing reference errors. So let's save this and then run this with node. And this is exactly what we expected to happen. We notice that a prints, so var a leaked out of the block, but b and c both throw errors, which shows that let and const are contained to the block, which is the first major difference. So now let's do some reassignment. So I'll start with let. I'll assign a value, then change it. This should basically work because let is meant for values that update over time. Then I'll do the same idea with const. I'll assign it once and then try to change it, but const does not allow reassignment of binding, so this should throw. So we can do let counter equals 1, counter equals 2, console.log counter after reassignment. Const status text ready. Oops. Status text equals done. And then console status text so let's run this, save it. So we can see that let has updated successfully, but const has refused to change, and that's intentional. It basically prevents accidental mutation of something that was supposed to stay fixed. So now let's moving on to timing behavior. I'm going to try to read a variable before it's declared. First with var, I log it before I declare it, and then after, and then with let, I'll do the same thing. So let's do console log and we can call this old value. Var old value equals 10. New value. Let's make this 10 as well. Let new value. Save this. Run node demo.js. So after running, we can see the difference. Is a var just silently gives undefined before it's declared, as seen here, and let actually throws, and that early error could be very helpful because it stops you from using a value before it's initialized. Now moving into the last bit of information regarding loops and callbacks. So I'm going to essentially build an array of functions in a loop, first using var and then using let, and each function is supposed to remember the loop counter from its own turn. Let's delete this. Let's create our array. So this is good. Fonts var push arrow function. And then we close this. Now let's move on to the let function. Oops. For up. This is good. And let's finish that off. So if we save this first, let's run it. Demo.js. This is the issue here. Oops, jar. Save, and let's retry that. So with var, essentially what's happening here is the loop counter is shared across every iteration, so all the functions end up printing the same final value. While with let, each iteration gets its own block scope, so each function remembers the correct value for that iteration. And what you can see here is that you can see a clear difference. So with var, the version prints the same value 3 times, while with let, the version prints 0, 1, and 2, the way that you kind of expect. And this is why one of the reasons let fixed a long-standing pain point in older JavaScript. So putting it all together, var leaks out of blocks, can be reused silently, and is hoisted in a way that can hide bugs. Let is block scoped and can change when it needs to. And lastly, const is block scoped and cannot be reassigned, which makes intent obvious. That is all for this midterm evaluation project. Thank you so much. I hope you enjoyed.